Joyce. Hi, Gerardo. We are actually starting with test corrections. A few quick unanswered ones that people could get turned in. Then we're going over homework questions on 10.2. I keep on thinking everyone's in chapter 8, and I really don't know why today. I apologize. Going over questions on 10.2, and if we have time, we'll progress to 10.3. But if we don't, we will just deal with it. Nice thing is 10.3 isn't too crazy. We're going to talk about more error beyond alternating series, which will be very productive or very useful, I think. 10.3 is error. 10.4 has to do with intervals of convergence for anything, not just, once again, geometric. 10.5 keeps going with convergence a bit. So if we can get past the beginning of Taylor's series, I think we should be able to go a bit faster. But the nice thing is to be honest, in my other book, pretty much the whole chapter was Taylor's series. So they have condensed a big idea in one section, hence why we have questions. On our test, let's start with number 2. Give me the important information. Oh, where is he? Oh. It's been an interesting technological day. Try again. Turn off. Turn on. How's life for you guys besides calculus? Oh, wait.
We did 6 sections of government.
That's why I'm not going to do
Well, I'm caught up except for today's one.
Oh, that's good.
Yeah.
Go team. So you caught up on all sorts of stuff.
Yeah.
Okay. We have a basketball game Saturday, 6.
It's Saturday.
Where is it? What's the name of it? It's really in Seaton?
I think so.
Oh, it's in Seaton.
That's what Maggie said.
That's nice
that
for
it would
me.
be,
That might be Bonitas High School.
but that's not who it was.
I don't know where it is. That's where it is,
Yeah.
at least. I don't, is it just because we have to have like
It's
a
a
impartial?
neutral. Yeah.
Oh.
I don't know where the game went.
Okay, who has the info? Sorry, I'm back.
It says
Just give me the important stuff. Who's the series?
negative 1 to the n over n factorial is 1
Okay.
Maybe it's not done.
Negative 1 to the n.
over n factorial.
Okay, what are we trying to find?
And the sum and state the number of terms needed to arrive at
The total sum? Or does it say the certain partial sum?
when a partial sum is within 0.005.
What is that whole within thing that they're talking about? Mm-hmm.
So A7 plus 1 is less than equal to
Mm-hmm. What was it? Point.
0.005. 0.005.
Oops.
Easy.
Okay, so then using our spiffy-diffy formula, and since this is an alternating series, remember we're not going to learn how to do remainder until section 10.4, 10.3, 10.4, 10.4, 10.4, 10.5. For anything else besides alternating. So the alternating right now says, hey, error, or S minus S sub n, which we're trying to figure out, is going to be less than a sub n plus 1, which is less than 0.0005. Okay, hold on. How do we make an expression? Because we don't know anything going on about that, right? Especially since they didn't even tell us. What do we know about this guy?
1 over n plus 1 factorial.
It's absolute value, so ignore the negative 1, doesn't matter. And all we have is 1 over n plus 1 factorial. Needs to be less than 0.0005. How do you undo a factorial? You don't. Then what do? Well, you could go ahead and see who this guy is, right? And you could change this and say, hey, okay, so n plus 1 factorial has to be greater than 1 divided by 0.0005. And what did you guys get who did that?
1 over 2,200.
2,000. So then it ended up being 2,000. So we need to figure out what factorial goes over 2000, and my ones that did it, which factorial did it?
No, I don't know what I did in my calculator. But I gotta push the right decimal.
Just keep on doing factorials. So like 2 factorial is 2, 3 factorial is 6, 4 factorial. We need to find one over 2000.
7.
I think it's 7.
Because it's supposed to be,
Double
it's
check
7.
I did 6.
6 is the answer, but 7 is, no, yeah.
Oh, plus 1.
13,007.
13,007. What's 6 factorial? You can divide by 7 with that one.
700.
Ah, so 6 factorial is not big enough, huh? So we need 7 factorial. How can I write this? 7 factorial is greater than 2,000, which we're going to set equal to n plus 1 factorial. We can just discount the factorials and say, sweet, so n plus 1 has to equal 7, so n has to equal 6. So what partial sum do we need, or how many terms? 6. That's where it gets a little tricky, because the 7 is the one that bumps it over, but remember that is the n plus first, so take away 1. So we're going to find the 6th partial sum, or the 6th partial sum would have an error less than 1 over 7 factorial, hence why it would work. Does that make sense? Anything else on test corrections that we're stuck on? Okay, so let's go and get those test questions turned in if you have not yet already. Otherwise, let's go back to homework and figure out what's going on and why we're so lost.
Is that you need to stick with? Or
My guess is based on time, as you guys turn in things. They're probably going to answer questions. You guys are going to finish homework tonight for tomorrow. So my people that are gone, like Gerardo, if you're already more caught up, then it's not a big deal for being gone today. Joyce, I'm not sure exactly how far you got in homework.
she did it all with her eyes closed.
With her eyes closed
She's a G.
at 11 o'clock last night. I forget what time you guys were texting.
She sneezed and it all happened.
Who was sneezing? Magical sneezes, Joyce, I didn't even know. Okay. I need you guys real quick before because I'm just importing algebra notes real quick so that they are all ready to go. Before we get into homework, number 1, have your homework spiral open. Number 2, have your book out if you have one. If not, I have a few extras up there. Remember, you can go borrow. I think Gerardo has one. I think I have one. There might be a couple others.
I stole it.
Nice. The paper-covered ones are both BC. And I have another one in the back.
I want the only answers.
You want Gerardo's?
No. I'll give it Steve's.
There's one underneath the blue book by my computer, Georgie.
Guys. Guys, I have all the answers. Is this the teacher edition?
No, sorry, it's not that good. I have that one. Why is my Google Drive not working?
Because the brother was attacking school and we got off again. You know the word of God is alive and active. Sharp for that.
Everyone was singing it.
I sang it, I looked at him straight, we made eye contact, he waved at me, I gave him a thumbs up. He became my dad.
You can enough eye contact here.
But like honestly, those songs, I'm gonna remember all of those
For sure.
times.
If I hear it, then I'll start singing it.
But even when I'm reading the Bible and I come across like where verses and
It's like
stuff,
automatic.
I like have to sing it. I can't just say it.
Yeah,
This
it's
is-
automatic.
this is right.
Archeos, I want you to go ahead and in your notes, go find me the Taylor polynomial, Maclaurin polynomial formula. Let's start there.
In our notes.
So that you have them to access.
Oh shit, no.
Wow, my Google Drive is completely not responding.
It's the interwebs.
It's just weird.
Someone's hacking us.
Trying to restart it. Alright, kiddos, so starting at the very beginning of homework, as I'm trying to bring up things, we'll see if it actually works. When it says use the formula and definition to construct the fourth order Taylor polynomial x equals 0, all you're supposed to be using is the formula that we have written down in our notes, right? Wow, it's not even looking cute.
Shanghai.
Does Google just randomly decide not to have this? It's the
Maybe everybody in the world's on the Google Drive right now.
Except for the people in China. The search was telling me about how he couldn't use Google. Yeah, you can use Google.
Yeah, they can't access. Right, Jack? You can't access anything. That's why, like, they can't access my website. It's a Google site. Like for summer packets and stuff. Oh no, okay. It's the network here. Is
Oh, well, who in China wants to access your Google
what? It's the summer packet people.
I do.
government
I
wants it.
realize, like,
The government wants it because Miss T has so much information that is so wisdom-ish and wise.
That's
That's what,
say that.
that's what I meant to say,
that's
wise.
a word.
Okay, come on. Look, it has a wheel. Maybe?
The wheels on the Google Drive go round and round, round and round,
Look at
round
this,
and
this is
round.
awful.
The wheels on the Google Drive go round and round.
Who
With all the
crashed
trick
Google?
players. Do they have collision insurance?
Or just liability.
It's like- It was cheaper. They raised the deductible.
I found out none of my cars have collision insurance.
Nice.
Yeah. But it's because they all are like really old cars. So it would
That means working for or it's not working?
Oh, this is such a struggle.
Shandai. I gotta call her. She's got a question.
Maybe we could take pictures of algebra notes and import it? Guess we could try that. Alright, anyway. Let's forget that. Hopefully algebra 1's not until plus today. Okay, so. There we go. So real quick, on number 4, when we, I don't even know how to go through homework questions, guys, because it's like everything, but we'll just try. Stop. That page below.
Yeah, that was very nice to do with the show. I'm looking it up.
Nice.
I'm very curious.
Spoiler.
Sorry, guys.
But I like that she said it has to be about him because
It's
he
not.
is a Democrat. But it's also the Ronald Reagan Library. So there's that too.
Yeah, you know how that works. So for number 1, you were supposed to find the first derivative, second derivative, third derivative, etc., etc., etc. You're plugging into the Taylor polynomial, so that means f of x is approximately equal to. How do you build a Taylor polynomial again?
You gotta count. So we have to do the derivative?
F of 0 plus f prime 0x plus f
Or
of
prime over 2 factorial times x.
How far do we keep on going if it says the fourth order?
4.
So it's to the fourth.
So it's to the fourth, right? Or the fourth derivative?
Wait, we go to the fourth? Oh yeah, that's one way.
So why was this a little bit annoying?
Because it's such a
You had to find the derivative
Let's
four
plug
times.
it into the cap.
But that was not supposed to be all of homework. That was just number 1. Just to be like, oh, that's the long way. Okay, that sounds fun. Number 5. It's also an odd. You can check in the back. How the directions change.
You can use the
3 non-zero terms.
Wait, use the table of Maclaurin series at the end of the section. What's the table of Maclaurin series at the end of the section? These special ones, I was like, these might become an endeavor soon,
Right, but like.
From our
it's
notes.
specific.
right?
But it has to do with synapse.
Yeah. Now look up.
But
See? Okay, so what do we know about sine? He's odd. Oh, that's right. He's the odd powers of x's with alternating signs over their factorials, right? Now, what changes when number 5 says, hey, by the way, not just any sign, I want instead sign of 2x. Now, multiply by 2.
Plug in 2 x's.
Yeah.
Include 2x, right?
This was a lot easier than I should have.
I just don't
So
know.
instead of x, we're going to have 2x. Instead of x cubed, it's going to be 2x cubed.
Over 2 factorial.
Instead of x to the 5th, it'll be 2x to the 5th. How many are we supposed to do?
They're the first 3 terms.
Oh, okay. First 3 non-zero terms. And the general term. This is where some people were getting stuck.
Negative 1 to n times 2x to the 2n plus 1 to the 2n plus 1 factorial.
Where do you come up with that?
It's like,
No,
no, but I see. I see.
But it is alternating, right? So don't you know that we have to have an alternator?
And then the 2x is getting raised to the odd power, and then the factorial is going to be an odd factorial. So that's over.
If we start at n equals 0, then we could do negative 1 to the n. That's true. If we start at n equals 1, then we'd have to make it n plus 1. 2 x's are repeatedly getting raised to odd powers starting at 1. How do you make an odd number?
N plus 1. I don't know what it is. Oh, but
Not n plus 1.
allowed to make it odd. No. So yeah, that's what 2 plus 1.
We could do 2n plus 1. Because 2n would be even numbers and plus 1 would make it odd. So if we're starting at n equals 0, then 2 times 0 plus 1, there we go. 2 times 2 is 4. 2 times 1 is 2 plus 1 is 3. There we go. 2 times 2 is 4 plus 1 is 5. And then we have all over the odd number that we just formed, right? Factorial. Does that make sense?
Yeah.
And they said use table series. If it says series, how should I finish this? Yeah, plus dot dot dot. Otherwise, I just have a polynomial. I don't have a series. And number 1, it was just the polynomial, so I stopped it. Give the interval of convergence.
All real.
Sine has all real numbers, remember? Sine has all real numbers. And we'll talk more about why that is what it is when we come to it, but remember for right now, we are building upon those special ones. And these special ones, the interval of convergence, we know for the first one, x needs to be between 1 and negative 1. For the second, third, and fourth, we know the interval of convergence is all real numbers. Oops. Okay. Number 8, he's an even. Let's see how you guys did. Hold on, who we building off of?
Yeah.
Uh-huh. So we're going to have 7x times each of the terms of e to the x. Who are e to the x's terms?
1 plus x plus x squared.
So we're going to have 7x times, is that okay? 1 plus x squared over
2 factorial.
x cubed over.
3 factorial.
We'll get back to the general terms in a second, yeah? Let's go ahead and first build what's going on. So then times 7x, we have 7x plus 7x squared plus 7x cubed plus 7x to the 4th. I might have gone a little too far as how many terms, but we still need to get our general term. General term, isn't 7 just chilling? Could we just put a 7 right there? And then can't we make it x to the, if we're starting at 0, we could do n plus 1. When you guys were checking in the back of the book, did it seem as though they were starting at n equals 0? That's what I assumed from what I heard. For instance, on number 5 in the back, was it
Yeah.
negative 1 to the n or to the n
Yeah.
plus 1?
Yeah.
Okay, so we're starting at n equals 0. Just for the sake of being able to match. All over n factorial, right?
Yes.
Because 0 factorial is 1, 1 factorial is 1, 2 factorial will start showing up at n equals 2. Does that make sense, guys? Interval of convergence, what's it based off of? E to the x. So all the numbers. Number 11, this is the one, no, you're talking about number 13, Nana.
11 also is just the general term.
Who should we build off of?
1 over 1 minus x.
Mm-hmm.
What do we do? Oh,
So we start with our 1 over 1 minus x, which is just the geometric, just keep on multiplying by x, right? Now how do we bring in the 1 over 1 minus x cubed?
multiply 1 x.
Plug it in, plug it in.
Okay.
Does that make sense?
And what about the top?
So then x cubed squared would be x to the 6, x cubed cubed would be x to the 9. Then we bring in the x on top. Then we just multiply everybody by x. So that'd be x plus x to the 4th plus x to the 7th, struggle, plus x to the 10th. The question was on the general term, and I think, Gerardo, that was your question too with the patterns. How do I find a pattern that goes from 1 to 4 to 7 to 10?
Plus 3, but
2 minus 1? No.
So that'd be all the odds.
Yeah, it looks like 1 plus 3. Right? Plus x to 1 plus 3 minus 4 plus 3 is 7. Right? Yes?
Well, in these ones, remember, this would be n equals 0, n equals 1, n equals 2, n equals 3. So if I had 2 times 0 plus 3, that should have been a 3, and it's not. And then 2 times 1 plus 3,
Wait, can we just do
oh, just n plus 3.
yeah, it's 10 plus 3.
0 plus 3 would be 3, 1 plus 3 would be 4, 2 plus 3 would be 5. That's not going to work.
I'll let you multiply.
3 plus 1.
Ah, 3n, how about that? And then if I do 3 times 0, that's 0 plus 1. 3 times 1 would be 3 plus 1. 3 times 2 would be 6 plus 1. 3 times 3 would be 9 plus 1. Got it. You can say x to the 3n. Maybe you guys could think about this in terms of arithmetic series. If you're adding 3 over and over and over again, repeated 3s would be 3 times n. For arithmetic, we did 3 times n minus 1 because of the jumps and whatnot, but we need multiples of 3. Hence the 3n. Interval of convergence? Front row. Negative 1 to 1. So you would set x cubed, right? Less than 1, greater than negative 1. And you do end up with x's within negative 1 to 1 yet again. Alright, number 13 was a beast. He was the one that Amanda and I were talking about just a second ago. So let's peek at him.
Are we doing this in pencil or should I be doing it in pencil?
Theoretically, you can be doing it in pencil.
Or candy?
Technically, probably pen, but theoretically, yeah, pen. What becomes difficult when it says generated at, and the value they gave us was x equals 2. The function, I'm rewriting it the way I would like, and
So
centered
centered?
around. What do I know about centered around?
X minus c, so x minus 2.
Somehow I need to rewrite this as having an x minus 2. And I can do that, right? But the problem is those aren't equal until I do what?
Subtract 2. Do I have to make the thing negative?
Don't I have to offset? If I subtract 2, I have to add 2. Does that make sense? Then I say, okay, cool, no big deal. 1 over 3 plus x minus 2. And how do I make that match? Who do you think I wanted to match with?
1 over 1 plus 1 minus x.
Yeah.
So we can just subtract, or make it negative instead.
Yeah, so I'm going to go ahead and keep going and say, alright. 1 over 3 minus a negative x minus 2. Right? But who still doesn't belong? Mm-hmm. So I need to go ahead and factor out a 3. Now, if you want to, I don't know, I feel like it's a little bit creative right now. Couldn't we theoretically multiply top and bottom by 1/3?
And our first one would be 3.
1/3. Got it. So I'd have a 1/3 on top, that'd be our ace of 1. As we distribute in, we have the 1 that we have so desperately, I don't know if it's desperately, but that we wanted. Negative 1/3 can just come out of our x minus 2. Whew! Finally, I can see who is my ace of 1. 1/3. Looks like a 9. Who is my r? That. Now can I build my Taylor polynomial? What do they want? Polynomial series. Hey, they don't say the general term though, right? Boozy. So f of x is equal to 1/3 plus, I'm multiplying by negative 1/3 x minus 2, right?
So negative 1.
So negative is going to alternate. X minus 2 plus,
127.
got it,
X minus 2 squared.
got it. Then 180 first.
We have to have a factorial. Is that like included?
Well, remember, we're building on a formula that we already know that has already taken into account the factorials. Now, what if you got totally stuck on this and you're like, I don't know what to do?
That's what I did right now.
Could you try to take the first, second, third derivative?
Yeah.
Plug in 2 instead of 0. And then plug in 2, where are our notes? Remember, the formula includes centered at for Taylor's, right? So we could have just literally found for centered at, literally found our function plugged in 2, found our derivative plugged in 2, and then x minus 2, found our derivative plugged in 2, over 2 factorial plugged in x minus 2 squared. But what would this have ended up simplifying to? What we have written down, right? Does that make sense? So both ways work. Like, there is no, like, I'm totally stuck necessarily, unless you don't know how to read the directions or what they're asking for. But you could always go back to that formula if you want. What we're doing are shortcuts. True?
Yeah, because
Is there any other, for those of you guys that went on homework, is there anything else that we really need to look at?
16 if possible. Because it's
Use the methods of example 5 to find the Taylor polynomial of order 3 generated by f.
it's just a big F, so I don't know.
If I were you, I was looking back at example 5. I wanted to give you a polynomial to work with.
So can you just find the first, second, third
Yeah.
derivatives?
Yeah, the first, second, third derivatives are way easier than trying to make it match anything.
And then at x equals 1, what would you do differently? You would
Remember, you plug
x
in
minus
1
1.
for f of 1, f prime of 1, f double prime of 1,
Got
and then do x minus 1,
got it.
plugging into the formula. Okay then, with that, let us go ahead and let's see, I have an FRQ I want us to look at, but instead of that, considering you guys and considering where you're at in the sense of not quite done with homework, let's just put it that way. Let's instead go check out one of those long answers. Sound good? Let's go check out number 24. Alright, any of you guys up to that in your homework that you wanna, oh, a few of you have written it down. Okay, to play with it in your notes, oh my goodness, come on, bub. Struggle, I wanted to at least peek at it.